At the end of the Second World War, German tank production found itself in a very difficult position. The problem was not only in the bombings of factories, the loss of large territories, and the shortage of resources. The accumulated errors in planning the development and production of armored vehicles also began to show, as did instances of dishonest competition between companies. Let us try to understand how, in the last year of the war, under a new head of the Tank Commission, the Germans attempted to reorganize their tank industry, and what came of it. By 1944, German tank construction was in an extremely difficult state. The Germans had practically failed in the development of light tanks. The official order for a new unified reconnaissance tank was issued on September 15, 1939, and at the beginning of 1942, the Mayen Company presented the first prototype, which became better known as the Luchs, or simply the Man Reconnaissance Tank. It was planned to build 800 Luchs, with the first 100 tanks expected to roll out of the workshops by April 1943. Instead, production continued only until January 1944, after which it stopped completely. A catastrophic result for 4 years of war. The Czech companies Škoda and BMM received similar orders much later, on July 31, 1940, yet managed to present their prototypes earlier, and their new model turned out to be almost better than the German Luchs. With the support of the Armament Office, German companies managed to remove their Czech competitors, but they were unable to handle all orders and effectively left the Wehrmacht without new reconnaissance tanks. By the end of the war, the German tank industry had no promising light chassis in serial production. This result was achieved entirely by the tank builders of the Third Reich themselves, without any help from foreign saboteurs or spies. There were also serious miscalculations in the class of tanks weighing around 20 tons. The concept of a single base for a medium tank had been conceived back in 1937, but throughout the entire war, the Germans continued to produce armored vehicles based on the chassis of the third and fourth models. Despite having similar characteristics, they had fundamentally different designs, the potential of which had already been exhausted by 1943. Yet even with the Tigers and Panthers in service, the Germans could not completely abandon the production of 20-ton chassis, since they were needed for mass-produced tank destroyers, self-propelled anti-aircraft guns, and howitzers. To fill this niche, companies worked on replacing the outdated 3s and 4s. But for various reasons, all development programs for new models remained only on paper. As for the Panther and the King Tiger, these were problematic tanks with low reliability. This is usually explained by wartime conditions and the extreme haste in design and production setup. That is partly true, but another reason was the inadequate approach of the Armament Office, which had been failing even before the war. For example, when developing transmissions for engines with 700 horsepower, the Germans for some time ignored traditional and planetary gearboxes in favor of very expensive and exotic shaftless designs. As a result, in an attempt to reduce the cost of the Panther, they hastily created a conventional gearbox whose reliability left much to be desired, while the planetary gearbox was never tested on the Tiger before Germany's defeat. Facing the impending catastrophe of the war's end, the Germans needed to produce as many inexpensive, standardized armored vehicles as possible, which would simplify both factory production and field maintenance. But German tank engineering continued to supply the Wehrmacht with problematic Tigers and Panthers, as well as an entire zoo of vehicles in the light and 20-ton weight classes. It became necessary to improve the design of promising tanks and finally conduct the long-overdue unification. These were the problems German tank specialists tried to solve during the final months of the war. In December 1943, the director of the Henschel works in the city of Kassel, Gerd Stieler von Heidekampf, headed the Tank Commission, replacing Ferdinand Porsche in that post. As an experienced manager, von Heidekampf believed that the German tank program was utterly senseless. In his words, heavy industry lacked the mass production experience that the automobile factories possessed. The development of new designs was never carried out rationally, which led to an excessive number of different models, and some designs were simply too complex. During von Heidekampf's time, the Tank Commission lost its role as an independent competitor and a generator of new ideas, but overall, German tank building began to develop more coherently. Under these conditions, the Germans finally set about their tank menagerie. On January 4, 1944, at a meeting of the Tank Commission, the requirements for a new medium tank were approved. It received the name 3-4. As the name shows, this was a new vehicle on a single chassis that combined the best developments from the 3 and the 4. From the 4, they took the turret with the gun and the cooling system. From the 3, the gearbox and the steering mechanism. The engine remained the same, but the final drives were reinforced on the 3 pattern. The running gear was made completely new. It consisted of 6 road wheels about 26 inches in diameter on each side with internal shock absorption. The suspension on leaf springs was done on the 4 pattern, and the tracks about 21 inches wide were made with an eye to the heavy Tiger II. Ground clearance was raised to 20.5 inches. The new hull received well-sloped armor. The thickness of the upper glacis was about 3 1/10 inches at an angle of 50 degrees. The upper part of the side was protected by armor about 1 2/10 inches thick at an angle of 36 degrees. True, to simplify things, the Germans decided to supply the turret with a flexible electric cable so it could not rotate a full circle, only 270 degrees to each side. On the other hand, the ammunition load increased to 100 rounds. At the same time, a tank destroyer was being designed on that same single chassis. It was classified as light since German tank destroyers were divided only into light and heavy. On the single chassis, they mounted the successful casemate from the Jagdpanzer IV with a 75mm gun and frontal armor, 3 1/10 inches thick at an angle of 50 degrees. In March 1944, Department No. 6 of the Ordnance Directorate signed contracts for the production of 3 prototype single-chassis vehicles. In June, the start of production of the new medium tank at the Krupp Works was discussed for February 1945, but a month later it was decided to throw all efforts into the production of a self-propelled gun based on the same chassis, which received the name Panzer IV Long. According to plans, the Alket Works and the MIAG Works were to switch to production of the new vehicle in November 1944, Krupp in January 1945, and the Wehrmacht and Nibelungenwerke Works in March. Thus, a whole menagerie of 6 different vehicles was to be replaced by a single platform. That was a sensible decision because the single tank destroyer was armed with a powerful gun, but unlike previous models did not suffer from weak final drives and an overloaded running gear. The Germans tested various types of suspension for the prospective chassis, and the Deutsche Edelstahl firm assembled an armored hull for the new tank destroyer in September 1944. But already a month later, the single tank destroyer program was stopped in favor of an even simpler and cheaper alternative. It was American aviation that pushed the final decision to standardize German armored vehicles. In November 1943, the Alket factory suffered massive bombings which caused production of the 3rd version of the Stugee assault gun to drop sharply. The Germans then decided to set up production of its analog at Czechoslovak factories. The firm BMM did not have equipment to assemble armored vehicles weighing about 40,000 pounds, so it designed in the shortest possible time a light assault gun based on the Czech light tank of the 38th modification. Later, at the insistence of General Guderian, it was renamed the tank destroyer Jagdpanzer 38. In armament and in the thickness of the frontal armor, the vehicle roughly corresponded to the 3rd version of the assault gun and to the 4th version of the tank destroyer, but it was much simpler and cheaper. Tight, with poor visibility, unreliable, and slow, the Jagdpanzer 38 had one decisive advantage: readiness for immediate mass production. On September 26, 1944, the High Command of the German Army announced the decision to deploy production of the Jagdpanzer 38 with the Tatra diesel engine at the Alket factory. This may seem strange. After all, the 3rd version of the assault gun and the tank destroyer planned to replace it on a unified chassis were by their characteristics far better than the Jagdpanzer 38. However, the command demanded that as many armored vehicles as possible be produced. Up to 1,000 self-propelled guns at Alket every month, although the mark of 500 assault guns per month that this factory aimed for was never reached. The Jagdpanzer 38 turned out to be the simplest, the cheapest, and the most suitable alternative for mass production. On October 4th, the Tank Commission decided to leave only 3 types of chassis in production: the light 38th modification, the medium Panther, and the heavy Tiger II. All self-propelled guns, reconnaissance vehicles, recovery and repair vehicles, and so on, were to be produced only on their basis, while other older chassis types were to be gradually phased out of production. At the same time, the program for a single chassis for the third and fourth versions of medium tanks was canceled. In response, Department No. 6 of the Ordnance Directorate reported that the 38th modification chassis was not adapted for production at German factories because of different equipment. In addition, the Czechs used a planetary gearbox, while the Germans traditionally preferred 3-shaft and shaftless schemes. The Alket Design Bureau, under Chief Engineer Michaels, immediately began reworking the Jagdpanzer 38 to German standards, simultaneously eliminating its numerous shortcomings. On the new tank destroyer Jagdpanzer 38D, the suspension, final drives, and steering mechanism were reinforced. The slope of the lower side plates was abandoned, and the hull was made wider. The air-cooled Tatra 103 diesel engine, rated at 220 horsepower, was coupled via a reduction gearbox and shaft to a 5-speed transmission. The maximum speed was 25 miles per hour, and a fuel supply of 100 gallons was enough for 310 miles on good roads and for 186 miles off-road. The designers provided the possibility of increasing the track width from 13.8 inches to 18.1 inches, and the transition to a new suspension with buffer springs allowed the permissible mass to be raised from 36,800 pounds to 44,000 pounds. 3 armament options were proposed: 75mm guns of 2 different types with barrel lengths of 48 and 70 calibers, and a 105mm howitzer. Based on the 38D chassis, the Germans designed the reconnaissance tank Aufklärer 38D. The hull was made longer and lower, the frontal armor was reduced from 60 to 30 millimeters, and the total weight decreased to 30,800 pounds. The gearbox ratio was changed, increasing the maximum speed to 32 miles per hour. 2 armament options were proposed: an open turret with a 20mm automatic cannon and a machine gun, or a 75mm gun without a muzzle brake mounted in an open fighting compartment. It is worth noting that the turret, gun mount, and diesel engine were standardized with those of the armored cars. The result was a lightweight, high-speed tank only 5 feet 5 inches tall with a ground clearance of 20 inches. Based on this chassis, they plan to produce a light recovery vehicle, the Kugelblitz, anti-aircraft self-propelled gun, an armored personnel carrier, and a self-propelled 120mm mortar. By launching the new light chassis program, the Germans managed to solve several problems at once. The army was finally getting reconnaissance tanks, while a strange mix of 5 different self-propelled guns armed with 75mm, about 3-inch cannons was to be replaced by 2 standardized models, more advanced tank destroyers and reconnaissance vehicles. At the same time, outdated chassis were finally being phased out of production. In January 1945, the Germans planned to produce the first 5 new tank destroyers at the Alket factory by March, and then ramp up monthly output to as many as 800 vehicles by December. The Wehrmacht plant was to build its first 5 destroyers in July and reach a rate of 300 per month by December. In March, the plans were revised. Alket prepared 2 prototypes by April, with the first serial self-propelled guns expected in June. On April 5th, the Zahnrad Fabric Company shipped gearboxes to Alket for assembly completion, but the further fate of these tank destroyers remains unknown. Production preparations were interrupted by the end of the war, factory documentation was destroyed, and the captured prototypes could easily have been mistaken for ordinary light tank destroyers and sent for scrap. As for the reconnaissance tanks, their production was planned to be organized at the MIAG factory. In January 1945, the first 5 tanks were scheduled for completion in March, followed by an increase in monthly output to 300 by December. In March, the plans were revised again. Instead of reconnaissance vehicles, the chassis was to be used for tank destroyers and recovery machines. The gun mount had already been tested in Kummersdorf in February, but work on it was expected to be completed only in April 1945. German tank designers invested considerable effort in creating the new unified chassis, but the war ended just as they could have begun to reap the first fruits of their labor. According to plans, the heavy tank Tiger II remained in production, and no one intended to replace it. But the crude design required serious correction. There were no complaints about the armament or frontal armor thickness of the tank, but its reliability was another matter. During tests of a captured King Tiger in the Soviet Union, numerous problems were discovered. The vehicle, with only 276 miles on the odometer, suffered oil leaks from the right fan drive. track links and pins broke. The final drives and drive sprockets failed twice, and engine wear increased fuel consumption to an unbelievable 971 liters per 100 kilometers on dirt roads, about 2.5 gallons per mile. And that was not even the full list of defects. Ultimately, due to the lack of spare parts, the tests could not be completed. Engineers of the Henschel Company gradually worked to eliminate the flaws in their creation. In June 1944, the clutch in the cooling system drive was improved. The tracks, made from complex links, performed poorly both in durability and in the wear of the drive sprocket, so beginning in March 1945, production switched to regular tracks and drive wheels with 18 teeth. A new engine deck plate was developed. To make engine access easier, the size of the hatch was increased. Its cover was divided into 3 sections and the grills were redesigned. According to Chief Engineer Erwin Aders, the new cover was planned for installation starting from approximately the 700th production tank. But of course, this never happened. The gearbox could handle the load, but due to its complex design, it still raised concerns. The Germans were worried that its production could be disrupted, and they considered switching to the gearbox from the Panther. However, this gearbox was too weak even for the 45-ton tank, about 99,000 pounds, and was plagued by failures of the third gear. A good alternative was the planetary gearbox from the Pulschengetriebe Company, designed under the supervision of planetary transmission expert Erich Puls. It had a very simple layout with 8 forward and reverse gears, providing an excellent speed range. This gearbox successfully passed bench tests, and in 1945 it was planned to be tested on the Tiger II, but the war ended before that could happen. A separate topic is the tank's power unit. German designers never managed to perfect the Maybach engine. From November 1943, its power was limited to 600 horsepower at 2,500 revolutions per minute, instead of the original 700 horsepower at 3,000 revolutions. In March 1944, due to a new piston design, the compression ratio was reduced. An engine producing 600 horsepower was clearly insufficient for the 70-ton King Tiger, so a replacement was needed. On January 23, 1945, a meeting was held with von Heidekampf and Colonel Holzhauer of the 6th Department to discuss several alternative options. The Maybach company was working on a new engine producing between 800 and 900 horsepower with direct fuel injection. It was roughly the same size as the old engine, allowing for easy interchangeability. This also solved the problem of unreliable carburetors, which had been known for 2 years. This new engine was the favorite candidate, but Maybach never brought it to operational condition, and ultimately, testing on the tank failed to happen. Its main competitor was an air-cooled diesel engine developed by Porsche and Simmering. It was more economical and more powerful than the old one, producing between 750 and 770 horsepower compared to 600. However, according to Henschel's chief heavy tank engineer Erwin Aders, its X-shaped configuration required a complete redesign of the engine compartment, as well as changes to the armored hull and the track tensioning mechanism. However, it is known that at the Nibelungenwerke plant, this diesel engine was tested on the heavy Jagdtiger self-propelled gun with minimal modifications to the engine compartment. Even the upper plate remained the same. The fact was that Henschel engineers had prepared their own project to install this engine on the tank, featuring a new upper plate and a modified rear armor plate. It turned out that such major changes were unnecessary. The reason for the rejection was different. Production of the first batch of 100 such engines was planned at the Steyr plant instead of an aircraft engine, but production capacities were already needed for Tatra diesels, and it was impossible to retool the facilities twice. Besides those 2 engines, 2 other engines were discussed. The company Kleckner Humboldt Deutz worked on a 2-stroke, water-cooled V8 diesel rated at 800 horsepower. The new motor was evaluated as simple and torquey, and it fit into the engine compartment of the Tigers and Panthers, the Renault, but it was far from serial production. Finally, the companies MAN and Argus designed a 16-cylinder H-type air-cooled diesel rated at 700 horsepower, which was considered as a backup option in case the previous one failed. It is worth noting that out of 4 promising engines for the Royal Tiger, 3 were diesel. As for the armament, the Germans planned to introduce a sight with a stabilized field of view, a gun stabilizer, and a rangefinder, which required slight modifications to the turret, and to replace the machine gun MG-34 with MG-42. The company Kreiselgeräte received a contract to develop the gun stabilizer, while the companies Carl Zeiss and Ernst Leitz worked on sights with a stabilized field of view and on rangefinders. At the end of November, the company Krupp presented a preliminary design for installing a 105mm gun with a barrel length of 68 calibers in the turret of the Royal Tiger. The Armaments Office rejected this proposal because that weapon had not been adopted for service, and switching to separate loading ammunition would have reduced the rate of fire. According to the Urgent Tank Development Program, in April 1945, the Royal Tiger was to receive a rangefinder and a sight with a stabilized field of view, and in August a new engine producing from 800 to 900 horsepower. Next in priority were diesel engines, the gun stabilizer, and protection against poisonous gases. Until the very end of the war, the Panther remained a rather unfinished tank. Because of unreliable side transmissions, a weak steering mechanism, and problems with the engine and gearbox, it simply could not travel long distances under its own power. This happened for two main reasons. First, the Panther was very heavy by German standards, and major changes threatened to unacceptably reduce its production rates. Second, the company MAN was distracted by designing the Panther II, the transition to which stalled already in May 1943. After that, there remained only the implementation of developments from the Panther II on serial Panthers. At the meeting on the 4th of January 1944, in addition to requirements for medium tanks, it was decided to adopt new side transmissions from the company MAN and to prepare equipment for their production. This, however, encountered great difficulties. Despite all efforts, it was not possible to significantly improve the reliability of the serial side transmissions because the sizes of the gears and bearings were constrained by the track, the drive wheel, and the brake. Planetary side transmissions performed very well in tests, but their production was much more complex and expensive, and therefore the Military Technical Bureau of the Armaments Office opposed them. Discussions continued for a year and a half but led to nothing, and the Panthers continued to break down. In March 1944, production of the Panther Model G began, with a more production-friendly hull based on the Panther II type. Meanwhile, the company Rheinmetall continued work on a new turret, originally intended for the Panther II. On the 1st of March 1944, it presented a preliminary design of a turret with a narrow mantlet. Soon, the order was transferred to the company Daimler-Benz, which, in cooperation with Škoda, developed the Schmalturm narrow turret. Compared with the serial turret, it was simpler to manufacture, better armored at the same weight, 4.7 inches on the front, 2.4 inches on the sides and rear, and was equipped with a rangefinder, while the compact mantlet practically excluded ricochets into the hull roof. As on the Tiger II, it was planned to use the machine gun MG-42 and a sight with a stabilized field of view. By May 1945, the factories were to switch to the new Panther F modification with the Schmalturm turret, reinforced hull roof armor, new hatches for the driver and radio operator, and a STG-44 assault rifle in place of the MG-34 coaxial machine gun. Like the Tiger II, the Panthers were also scheduled to receive the HL-234 engine in August. In addition, a simplified 5-speed gearbox, new steering mechanisms, and diesel engines were being considered. In practice, by the end of the war, the Germans managed to produce only a few Schmalturm turrets and F-series hulls, but never assembled a complete tank. Finally, one cannot ignore the idea of installing the 88mm, 3.5-inch KWK-43L71 gun in the Schmalturm turret. This proposal was made by Krupp in the autumn of 1944, with the turret taken almost without modification. To fit the breech block, the trunnions had to be moved forward by 13.8 inches. In response, Daimler-Benz suggested increasing the turret ring diameter by 3.9 inches to 68.9 inches and placing the rear armor plate vertically to enlarge the internal space. At the meeting on February 20th, representatives of the Armaments Office reviewed the designs and decided to combine the company's efforts. Daimler-Benz was to develop a Schmalturm turret with a 68.9-inch ring and an angled rear plate, while Krupp refined the 88mm 3.5-inch cockpit and designed its installation. The total weight of the Panther increased by about 1 ton, 2,200 pounds, and perhaps that is why the Inspector General of Armored Forces, Wolfgang Thomale, believed that Panthers armed with the 88mm, 3.5-inch gun should be equipped with planetary side transmissions. The Germans planned to build a prototype Panther from structural steel with the 88mm, 3.5-inch gun in June, and if successful, to start mass production in the last quarter of 1945. It is impossible to cover all late war programs in one article. For example, we have not touched upon fixed guns or night vision devices. Yet even the examples listed above are sufficient to understand how German armored vehicle development evolved in 1944 and 1945, and what tanks and self-propelled guns the Wehrmacht would have used had the war continued beyond the spring of 1945. To the disappointment of enthusiasts of German engineering, the launch of the Panther II and E-Series vehicles was never seriously discussed. The first had already stalled in development in the spring of 1943, while the E-50 and E-75 projects were never completed. Instead, the Germans intended to end production of obsolete chassis and focus on light armored vehicles based on the 38T and 38D models, while simultaneously improving the designs of the Panther and King Tiger. According to von Heidekampf, by mid-1945 they aimed to reach monthly production of 2,000 light, 450 medium, and 200 heavy vehicles, though how this plan was to be implemented remains a mystery. Von Heidekampf also noted the following list of high-priority projects. Overall, by the end of the war, German tank design had begun to develop more rationally, and the existing and prototype tanks and self-propelled guns could well have matched the Allied machines. The problem, however, was that new models like the Centurion, Pershing, IS-3, T-44, and T-54 were already on the horizon, and inevitably, the Germans would have found themselves in the position of those catching up, with nothing left of their former advantage.